Let's discuss a very useful trick to find the direction of velocity of a point on a wave, right. So, in fact, let me just modify this. This is nothing but the direction. This can't give you the magnitude, but it can tell you whether the point is moving up or down, right. So, as you guys already know, this particular velocity, this particular wave has two velocities. One is your wave velocity, which is the net phenomena in which the wave appears to move. It's not actually moving forward or backward, but it seems to be going with v that side or coming with v this side. This is your entire wave velocity. But apart from this, you have what is known as a particle velocity. All these particles are moving up and down with their own velocities. If I pick up this particle, how do I know that at this particular instant of time whether it's trying to go up or trying to go down? Well, to do that, we just have to picturize it, right. So, this wave is moving that side. That means after a certain instant of time, the wave will look something like this. Everything will get shifted that side, right. So, if it gets shifted this side, this particular point will now be here, right. Assuming the same x for both, the y initially was this much, right, y1, and your y2 is here, right. That means the point has come down. If it has come down, that means the velocity of the point was downwards. That's how you actually visualize it. Let's look at that particular case now. Your wave is moving that side. How do I draw the wave after some time? It will look something like this. Something like this. Right. If I look at this particular point and if I need its velocity, assuming the x to be same, this point will now shift upwards, right. It will now go upwards because after some time it will be on that particular position. That means your point's velocity in this case was upwards. So, this is how you intuitively guess or actually verify the direction of velocity. Even if you actually if you know the equation of the wave, you'll have something like this: y is equals to a sine omega t minus kx, or omega t plus kx, or cos omega t minus kx, cos omega t plus kx, whatever. You'll have the equation of the wave given to you. You'll differentiate with respect to time. You'll put the value of x, you'll put the value of time, and then you'll get the velocity, right. And whether if it comes out to be positive, that means the particle was going up. If it comes out to be negative, the particle was going down. But that's the mathematical way of doing it. If you look at the wave, you can looking at the wave, you can say whether the particle is going up or down depending on the direction of the velocity, and the mathematics will also justify the same answer.